So you may perhaps have seen power supply modules like this one. You give them a fixed input voltage and their output voltage can be varied between 0.5 and 30 volts. They're very nice. Used in conjunction with a PC power supply like this one, you can make a fairly decent lab power supply like this one. So these things are all over eBay and they're not very expensive. So my mate bought one on my advice and we set about making a power supply out of it. This is the schematic diagram. I've connected the module itself to one of the 12 volt outputs on the power supply, and we're also connecting the 12 volt and 5 volt outputs directly to the front panel through fuses. We're also sticking some of these little digital voltmeter modules across the outputs so that you can see what they are actually producing. These are quite nice little modules. You give them a 5 volt rail, for example, to power the actual LEDs and the measurement circuitry, and then they'll measure between 0 and 99 volts. They're really quite nice, quite useful and very cheap. So with a switch added, the on-off switch, so you can turn the thing on and off. The circuitry looks something like this. It's all quite nice, really. Very simple circuitry, and you stuff it inside a box, basically, is the next thing you have to do. This is a pinout of the power supply that I found online, and it's wrong, which is very interesting. There appears to be several different pinouts for these things. Some look like this, and others look like this. So be careful. Yeah, you really have to watch out with these things. Make sure that you use the wires that you get with your power supply, otherwise you could be shorting things out when you connect it up. So then I set about making a box for it. So I basically made a model of the power supply, added on about 1 millimeter in height, and then made a case that was big enough to go around it, with some holes in the back for fans, and then designed front panel around the bits, which I'd already got from eBay. And this is it being waved around in 123D design. And then basically the case was designed around 5mm UPVC plastic that I had a whole pile of, which I'd rescued from a skip, or dumpster as you would call it in the States. So there's the top of the case, and there's the side of the case, and that's it in my G-code generation software that I wrote, and that's the front panel there, and there's the front panel there, and from that it generates G-code, and the G-code looks something like this. That's it. This is a simulation of it cutting the front panel. Yeah. Not much to report, really. That's what it does. It's always good to simulate the G-code to work out what your machine is going to do, because before you let the tool loose upon the actual material, you really want to be certain where the thing is going to go. So that about wraps it up. I hope you enjoyed that. I certainly did. Lessons learned during this project were, number one, PC power supplies can have different pinouts depending on the exact model that you happen to grab hold of, so be careful of that. Lesson number two, the little voltmeter modules can offer you only so much accuracy for £1.50. Got to watch out for that. Lesson number three, these little modules are quite complicated in their user operation, so I'm quite glad that we connected a DVM to its output to let us know what it's actually outputting when you're fiddling with the knobs, because it's not at all obvious by looking at the front panel on it. Yeah, I quite enjoyed this little project. Hope you did enjoyed the video. Cheers, bye. I'm crap at narrating.